Okay, our first question is solving the equation z cube minus 1, and we're going to write down our angles theta in the radian mode. So think about z cube minus 1 being your equation equal to 0. So add 1 on both sides, you get z cube equal to 1. So z is going to be the cube root or the third root of 1. So first I will try to write the real number 1 as a complex number, and it will be easier if you think about 1 as the point 1, 0 on the real axis. Now think about the polar form. The radius is clearly 1 and the angle theta on the positive direction of the x-axis is 0. So in polar form, the real number 1 is 1 plus 0i, that's the complex number, and in polar form it is going to be 1, the radius, times cosine of 0 plus I sine of 0. But since I'm taking the third root of this complex number and writing it in this form, I can use my formula. Now remember, the formula says that wk, the roots are of the form the modulus 1 and the third root of that, the positive third root of that. And then I write it as cosine plus the argument 0 plus 2k pi over n is 3 here, plus I sine 0, which is your theta, plus 2k pi over n3, where k is equal to 0, 1, 2 for our situation, because I'm allowed to go all the way to n minus 1, n being 3, I'm going to 2. Then if I use k equal to 0, I get w0 equal to 1, 1 is the cube root of 1, and I get k 0 means cosine of 0 plus I sine of 0, as simple as that. If I put k equal to 1, then I get w1 equal to 1 cosine 2 pi over 3 plus I sine 2 pi over 3. Finally, when I use k equal to 2, I get w2 equal to 1 times cosine 4 pi over 3 plus I sine 4 pi over 3. And these are the 3 roots of unity, 3 roots of 1. So what is W0? Well, W0 is going to be determined by the value cosine 0 and sine 0. And cosine 0 is 1, sine 0 is 0, so this is simply 1. W1 is cosine 2 pi over 3. 2 pi over 3 is in the second quadrant, where cosine is negative, sine is positive, and the reference angle is pi over 3. So I can say that this is cosine pi over 3 but negative plus I sine pi over 3. Similarly, W2, 4 pi over 3 is in the third quadrant. Both cosine and sine are negative. So this is minus cosine pi over 3 minus I sine pi over 3. That's the reference angle. Okay, so W0 is 1. W1, cosine pi over 3 is 1/2, so negative 1/2, plus sine pi over 3 is square root of 3 over 2i. W2 is equal to minus 1/2 minus square root of 3 over 2i. And these are the 3 roots of 1. So what are these 3? These 3 are 3 points on the 2-dimensional plane, and they all lie on the unit circle. So if you think about the circle that has the center 0, 0 and radius 1 unit, then the first root W0 is on the x-axis. The second one is in the second quadrant and it's somewhere here. That's W1. That's your 2 pi over 3. And the third one is somewhere here. That's your W2, where the reference angle is pi over 3, but the angle in the standard position is 4 pi over 3. So those are the 3 points that represent the 3 roots of unity. And in Cartesian form, you can say that this is the point 1, 0. This is the point negative 1/2. Your x is negative. and y is positive square root of 3 over 2. And W2 is the point negative 1 half, both x and y are negative, so negative square root of 3 over 2. All right, let's see what else we can do. This problem is solving the complex equation z cube equal to, or z cube plus 3 equal to minus 3i. Eventually, we're going to start writing this equation as z cube equal to minus 3i. So as usual, you have the Cartesian form of this complex number. We're going to change it to the polar form. And remember how I do it. The x coordinate and the y coordinate are both negative and both of them are negative 3. So I am somewhere here in the third quadrant. And I complete the triangle. This is negative 3, this is negative 3. And then I find r. R is going to be square root of negative 3 square plus negative 3 square, which is square root of 9 plus 9, that's square root of 18. Write it as 3 square root of 2. So that's your positive modulus of the complex number. Tangent theta is our next objective. Tangent theta is going to be negative 3 over negative 3, which is positive 1. Remember, your angle is going to be pi over 4. That's the reference angle because tangent theta is 1. But the angle in the standard position will be pi plus pi over 4. So I will say theta is equal to pi plus pi over 4, which is 5 pi over 4. So now I can say z cubed is equal to 3 square root of 2, the modulus, cosine 5 pi over 4, plus I sine 5 pi over 4. And I'm going to know how much are z, so I will say z is going to be this complex numbers cube root. So first say cosine 5 pi over 4 plus I sine 5 pi over 4, and then take the third root of that. So according to my formula, I will say wk equal to 3 square root of 2. I'm going to take the third root of that and the real cube root. And then I write it as cosine 5 pi over 4 plus 2k pi over 3 plus I sine 5 pi over 4 plus 2k pi over 3, where k is 0, 1, and 2. And then we're going to put the values in. So W0 is 3 square root of 2 to the power 1/3. And then I have cosine. If I put k equal to 0, I get 5 pi over 12. Plus I sine 5 pi over 12. W1 is k equal to 1. So you get 3 square root of 2 to the power 1/3. Then I get cosine 5 pi over 4 plus 2 pi over 3. Or you can say that this one is going to be of the form cosine of 5 pi over 12 plus 2 pi over 3, and then I can simplify it, plus I sine the same thing, 5 pi over 12 plus 2 pi over 3, and eventually the third root is going to be W2 equal to the same thing, 3 square root of 2 whole to the power 1/3 cosine 5 pi over 12. This time you are using k equal to 2, so you get plus 4 pi over 3 plus I sine 5 pi over 12 plus 4 pi over 3. And if I simplify it even further, I can say that W0 is equal to 3 square root of 2 to the power 1/3 cosine 5 pi over 12. And I know how to find these things using the half angle formula or the difference of the trigonometric formulas. Plus I sine 5 pi over 12. That's the first root. The second one, you are doing 5 pi over 12 plus 2 pi over 3. So if you multiply 4 on top and bottom, you're going to get the common denominator. And doing so, you will get 5 pi plus 8 pi, which is going to give you 13 pi over 12. So you will say that W1 is equal to the same thing, 3 square root of 2 to the power 1/3. And cosine 13 pi over 12 plus I sine 13 pi over 12. Then W2 is 3 square root of 2 whole to the power 1/3. And I'm going to get cosine, and remember again the same thing, you're going to multiply 4 on top and bottom to get the common denominator. So it's 16 plus 5, so 21 pi over 12. And I can actually simplify 21 pi over 12 by dividing by 3 on top and bottom. It becomes 7 pi over 4, or whichever way I can keep it as 21 pi over 12 doesn't bother me, plus I sine 21 pi over 12. And all these can be calculated using the half angle formula or the difference between two angle formula. Or you can use the calculator to simplify these answers and know them as points. So depending on how I want you to answer the question, you will do any further steps or not and get the answers done. So like we have found the cube root of 1, now I want the sixth root of 1. So I want 6 different complex numbers to be the solution. So remember, we have z to the power 6 minus 1 equal to 0. First step, you will write it as z to the power 6 equal to 1. And then you start taking the cube root. And I already know from previous work, this is 1 times cosine of 0 plus I sine 0. Always use radian. Then I can say W, K is going to be 1 to the power the 1 over 6 cosine of 0 plus 2k pi over 6 plus I sine 0 plus 2k pi over 6, where k this time runs over 0, 1, 2, 3, 4, 5. So I'm going to find out all 6 of these solutions. The first one is going to be 1 cosine 0 plus I sine 0. That's the easier one. W1 is going to be 1 times cosine. This is going to be k equal to 1 situation. So you have 2 pi over 6, which you can say is pi over 3 plus I sine pi over 3. Now I'm going to put k equal to 2 for W2. So I will get 4 pi over 6, which is 2 pi over 3. So 1 times cosine 2 pi over 3 plus I sine 2 pi over 3. Then W3, 1 times, you're using k equal to 3 now. So this is 6 pi over 6, which is pi. So I will say cosine pi plus I sine pi. W4, I'm using k equal to 4. So cosine 8 pi over 6, which is 4 pi over 3. And finally, we have W5 using k equal to 5. So I get 1 times cosine 10 pi over 6, which is 5 pi over 3, plus I sine 5 pi over 3. And finally, I would, because these are standard angles, each of them, you will have the reference angle equal to pi over 3 except W0 and W4 or W3. So this one, cosine 0 and sine 0 are 1 and 0 respectively, so I get 1. This is in the first quadrant, cosine pi over 3 is 1/2, sine pi over 3 is square root of 3 over 2. So that's going to be 1/2 plus square root of 3 over 2i. The second one is similar situation in the second quadrant. So cosine is negative 1/2 plus square root of 3 over 2i. The third one is a quadrant angle. Cosine pi is -1, sine pi is 0. So that's just -1. W4 is in the third quadrant, so I get -1/2 negative square root of 3 over 2i, as both sine and cosine are negative. W5 is in the fourth quadrant, cosine is positive and sine is negative, so that's what I get. So you can think of all of these 6 roots being 6 different points on the 2-dimensional plane on the unit circle. The circle of radius 1 centered at 0, 0. This one is 1, 0. This point over here is 1/2, square root of 3 over 2. This one is -1/2, square root of 3 over 2. This one is -1, 0. This being -1/2, negative square root of 3 over 2. And finally you have this one as 1/2, negative square root of 3 over 2 as the 6 roots: W0, W1, W2, W3, W4, and W5. Okay, let's see what else we can do. Solve the equation. So one more cubic equation: 4 square root of 3 minus 4i. So again, it's easier for us to understand this complex number. Since my x is positive, y is negative, I'm in the fourth quadrant. So it's here, 4 square root of 3 and -4. So r is easier. It's the square root of 4 square root of 3 square plus -4 square. So I get 4 squared is 16 times 3 is 48 plus 16, which is square root of 64, and that's 8. So the modulus is 8. Tangent of theta is going to be -4 over 4 square root of 3, which is -1 over square root of 3. Now remember, it's negative because it is in the fourth quadrant. So the reference angle is pi over 6. But the angle in the standard position is going to be 2 pi minus pi over 6. That's this much. So I will say theta equal to 2 pi minus pi over 6, which is 11 pi over 6. So when I find z, I do the cube root of this complex number, or I can write it as 8 times cosine 11 pi over 6 plus I sine 11 pi over 6, and the third root of that, which by my formula is wk equal to 8 to the power 1/3 cosine 11 pi over 6 plus 2k pi over 3 plus I sine 11 pi over 6 plus 2k pi over 3, where k is equal to 0, 1, 2. So W0 is going to be 2, of course 8 to the power 1/3. I'm using k equal to 0, so I get 11 pi over 18, and that's the cosine ratio. So we'll say 2 times cosine 11 pi over 18 plus I sine 11 pi over 18. W1, you are using k equal to 1, so 2 times cosine 11 pi over 18, and then you will get 2 pi over 3. So 11 pi over 18 plus 2 pi over 3 plus I sine the same angle, 11 pi over 18 plus 2 pi over 3. And finally, we do it for k equal to 2. So 2 cosine 11 pi over 18, and I get 4 pi over 3. plus I sine 11 pi over 18 plus 4 pi over 3. And finally, you can do the common denominator. So W0 is the same thing. Doesn't matter whether I write it again or not. Plus I sine 11 pi over 18. W1 is going to be 2 cosine, and see, I'm going to find the common denominator, so it's useful to multiply 6 on top and bottom, and I get 12 plus 11, so 23 pi over 18 plus I sine 23 pi over 18. W2, again the same thing. I'm going to multiply 6 on top and bottom. So I will get 24 pi plus 11 pi, which is 35. So 35 pi over 18 plus I sine 35 pi over 18. And these are the three roots. Now I'm not drawing them, but if you draw them, they are going to be three different points on the circle of radius 2 units centered at 0, 0. And finding 11 pi over 18, as we know, we can use the half angle formula, the difference between two angles, or we can actually go ahead and use these in the calculator. So for example, if you want to know how much is cosine 11 pi over 18, you will go to your calculator and make sure to be in the radian mode. So first change it to the radian mode and then do 11 times pi divide by 18, so that's your angle, and take the cosine ratio of that. Or I can do 11 times pi divide by 18 and take the sine ratio of that, and I get this much. So in either way, what we are trying to establish is the cosine ratio and the sine ratio of the argument angles for all three of these complex numbers, and hence know them as a point on the two-dimensional plane. So again, depends on how I want you to answer the question. Depending on that, you will do a couple more steps or not, but I'm going to skip this problem for the time being and go to our next one. So this one has given you the complex number 4 square root of 3 plus 4i and has asked you to identify these three roots as given in the graphs. So I will actually work this problem out first, and then we will come back to the graph and identify these points. So let me add a page and keep working. So we have been given with our complex numbers z cube equal to 4 square root of 3 plus 4i, pretty similar to the last problem. So z cube is 4 square root of 3 plus 4i. Clearly, this is in the first quadrant because both x and y are negative, positive. So I get 4 square root of 3 is the x value, y is 4. So radius is 4 square root of 3 square plus 4 square. As I said, it's pretty similar to the last problem. So you get 16 times 3, which is going to be 48 plus 16, that's square root of 64, and which is 8 units. Tangent of theta, again, it's in first quadrant, so easy. 4 over 4 square root of 3, which is 1 over square root of 3, and that's just pi over 6. So the complex number in discussion is 8 times cosine pi over 6 plus I sine pi over 6. So z is equal to 8 cosine pi over 6 plus I sine pi over 6 all to the power 1/3. So I will say wk is equal to 8 to the power 1/3 cosine pi over 6 plus 2k pi all over 3 plus I sine pi over 6 plus 2k pi all over 3, where k is equal to 0, 1, and 2. As usual, W0 is going to be 2 cosine pi over 18 plus I sine pi over 18. W1 is going to be 2 times cosine. So first and foremost, I will get pi over 18, and I will get 2 pi over 3 plus I sine pi over 18 plus 2 pi over 3. And this is when I use k equal to 1. Now I can go ahead and simplify this thing by finding the common denominator. So that will be 2 times cosine. Remember, pi over 18 plus 2 pi over 3 is pi over 18 plus 6 pi over 18, because I have multiplied 6 on top and bottom. So pi over 18 plus 12 actually. So that's 13 pi over 18. And we have done similar calculation already. So plus I sine 13 pi over 18. W2 is k equal to 2. So 2 times cosine pi over 18 plus, this is 4 pi over 3 plus I sine pi over 18 plus 4 pi over 3. Again, you are multiplying 6 on top and bottom to get the common denominator. So that's going to be 2 cosine 24 plus 1 is 25 pi over 18 plus I sine 25 pi over 18. So without wasting any more time, I would like to find these values, and say I'm rounding to 4 decimal places. So first I will do pi over 18 is my base angle, and I'm going to take the cosine of that. That's 0.9848. What does that mean? That this is 2 times 0.9848 plus I, and then I'm going to do the sine of the same angle, pi over 18. So pi divided by 18, I'm sorry, let's do it one more time. Pi divided by 18 and take the sine ratio of that. So that's 0.1736. That's your first solution. So when you multiply 2 with it and write it as a point, you will get 2 times 8 is 16, 2 times 4 is 8 plus 1 is 9, 2 times 8 is 16, 2 times 9 is 18 plus 1 is 19. So it's 1.9696 plus 0.3472I. So in other words, I can think of this thing as 1.9696, comma 0.3472 as a point on the plane. And then, as you can imagine, we're going to do the work for 13 pi over 18. So I will do all the work in calculator and just write the answer. So 13 times pi divided by 18. And I will take the cosine ratio for that. And then do not forget to multiply the 2. So I get negative 1.2856. 2856 plus or minus, we'll understand that when I do the sine ratio. And again, this is 13 times pi divided by 18, and I take the sine of that and then I multiply it by 2. So I get 1.5321. So 1.5321 I, and again, as I said, you can think of that as a point, negative 1.2856, comma 1.5321 on the plane. Then finally we have 25 pi over 18. So 25 times pi divide by 18. I do the cosine ratio of that and then multiply by 2. So I get negative 0.6840. And then I do the same thing for the sine. And again, it's 25 times pi divided by 18. I take the sine ratio of that and multiply by 2. And I get negative 1.8794. Or, as I have said so many times, you can think of this as negative 0.6840, comma, negative 1.8794. So these are the 3 points that are on the circle of radius 2 units. As you can imagine, the first root W0 is in the first quadrant, the second one is in the second quadrant, and the third one is in the third quadrant. And I determine by the signs of x and y. So now if I have to understand which point represents which root and which is the proper graph for this one. So the first one don't qualify is the one that I'm wanting to get, as you have one root in the first quadrant, one root in the second, one in the third. And see the other pictures, you have second one is second, third, fourth, the third one is first, second, fourth, and the last one is first, third, fourth. So the only one that matches my work is going to be the first one, and that's the solution to your question. These are the 3 correct roots. Okay, so again, we are going to see what else we can do with these things. So if I go to the next page, and we already found the work for this thing, so we will see the previous page for this work. The exact roots are going to be in terms of the radian measures, and if I wanted to round to 4 decimal places, then you will do the work in the calculator. Alrighty. So find the indicated power using De Moivre's theorem is the other side of the root power problem. So this time we are going to take the 5th power of 3 square root of 3 plus 3i. So if you remember the process, we first need to know the similar information, the r and the theta. So this one, both x and y are positive, so it's in the first quadrant. The y is 3, the x is 3 square root of 3. So r is 3 squared plus 3 square root of 3 squared and the square root of that. So I get 9 plus 27, which is 36. And that is 6 units. Whereas tangent of theta is y, so 3 over 3 square root of 3, and that's 1 over square root of 3 again. So theta being in the first quadrant is pi over 6. So when I take the 5th root, I am supposed to write it as the 5th root of the modulus times cosine 5 theta, so 5 pi over 6, plus I sine 5 theta, so 5 pi over 6. So this one is a little easier to compute. So first we need to know 6 to the power 5. So that will be 7,776 cosine 5 pi over 6. Now 5 pi over 6 is in the second quadrant. So where cosine is negative, so I can say minus cosine pi over 6, that's the reference I get, plus sine is positive, so I sine pi over 6. And pi over 6 cosine is square root of 3 over 2, so that's 7776 minus square root of 3 over 2 plus I sine pi over 6 is 1/2, so this is 1/2. And that answers the question for finding the 5th power of 3 square root of 3 plus 3i. Okay, so my next problem is doing similar thing for the complex number 2 minus 2i to the power 7. Again, get the point, find the polar coordinates. X is positive, y is negative, so we are in the 4th quadrant, 2 and negative 2. R squared is 2 squared plus negative 2 squared, so r is square root of 4 plus 4, which is square root of 8, and that is 2 square root of 2. Tangent theta is negative 2 over 2, which is negative 1. So reference angle is for 1 pi over 4, but this is in the fourth quadrant, so I will do 2 pi minus pi over 4 as my theta, which is 7 pi over 4. So when I'm taking the 7th power, I'm saying it's going to be 2 square root of 2, the modulus to the power 7, cosine 7 times 7 pi over 4, so that's 49 pi over 4, plus I sine 49 pi over 4. Now imagine 49 pi over 4. In each full circle, there are 8 of them. So if I do one circle, I get 8. 2 circles, I get 16. 3 cycles, I get 24. 4 cycles, I get 40. 4 cycles, I will get 32. 5, I get 40. And 6, I get 48. So doing the full circle for 6 times will give you 48 pi over 4. Then you have one more. So that is 49 pi over 4. So the reference angle clearly is pi over 4. And I get to say that this is 2 square root of 2. In the first quadrant, cosine and sine are both positive. So you get cosine pi over 4 plus I sine pi over 4. So it's pretty simple at this point. 2 square root of 2 to the power 7 is 2 to the power 7, which is 96. Square root of 2 to the power 7 is going to be 2 to the power 3 times square root of 2. Cosine pi over 4 is square root of 2 over 2 plus I sine pi over 4 is also square root of 2 over 2i. So I can cancel one of the 2's and I get 96 times 4. So 96 times 4 is going to be 4 times 6 is 24. And 4 times 9 is 36 plus 2 is 38. So 384 square root of 2 times square root of 2 plus square root of 2i. So now I can factor out the square root of 2 and make it look a little better. So it will be 384 times 2. So 2 times 4 is 8. And 2 times 8 is 16. 2 times 3 is 6 plus 1 is 7. So that's 768. 1 plus I. So as long as I have done the multiplication right, we are good. So one thing we can do, we can verify the powers. So for example, if I I do 2 to the power 7. I was supposed to get 128, so I actually did the calculation wrong. So let's do it one more time, just the power calculation. The rest of them should be good. So 2 to the power 7 is 128. And then square root of 2 to the power 7, you can think of that as 2 to the power 3 square root of 2. And then as I did, I canceled the 2 on the bottom with one of the 2's. So I get 128 times 2 squared, which is 4. So 128 times 4 should be 512. And square root of 2. Then I multiplied one more time, so I get 1024, 1 plus I. So that should be your answer.